Welcome to the fastest way to learn data structures and algorithms with this premium revision material. Today, we are mastering LeetCode 88, the Merge Sorted Array Challenge. This is a classic interview favorite, asked by tech giants like Facebook, Microsoft, and Google. Let us look at the problem statement. You are given two integer arrays, nums1 and nums2, both sorted in non-decreasing order. You are also given two integers, m and n, representing the number of elements in each array. Your mission is to merge nums2 into nums1, such that the final result is a single sorted array. Crucially, the merge must happen in place within nums1, which has an initial length of m plus n to accommodate everything. Imagine you are managing two queues of people. QA and QB, both lines are already sorted by height. You need to combine them into one single line, and that final line must also be sorted. The twist here is you already have a large enough room in the space reserved for QA to fit everyone. The goal is to merge them without creating a separate third line, keeping the process efficient and organized. The secret to solving this efficiently is the back-to-front strategy. If we start merging from the beginning of the arrays, we risk overwriting existing elements in nums1 before we have had a chance to use them. To avoid this, we use 3 pointers and start from the very end. We compare the largest available elements from both arrays and place the winner at the back of nums1. This way, we only fill in the empty buffer space first, and no data is lost. Now let us dive into the dry run. This is the most important part. Look at our arrays on the screen. Nums1 has the values 1, 2, and 3, followed by 3 zeros as buffer space. Nums2 has the values 2, 5, and 6. Notice the variable tracker box below, and the labeled pointers on the arrays. They will track our pointers p1, p2, and p as we move along. p1 starts at index 2, p2 starts at index 2, and our target pointer p starts at the end, at index 5. Look closely at the cyan and green highlights. At index p1, we have 3. At index p2, we have 6. Since 6 is greater than 3, we take 6 from nums2 and place it at index 5 in nums1. Notice p2 and p now move one step back. Next iteration. We compare 3 from nums1 and 5 from nums2. 5 is larger, so we move 5 into nums1 at position 4. p2 and p shift left again. Now, we compare 3 from nums1 and 2 from nums2. This time, 3 is greater. We place 3 at index 3 in nums1. Our pointer p1 moves back to index 1, and p moves to index 2. Continuing on, we compare 2 from nums1 and 2 from nums2. They are equal, so our code logic moves the element from nums2 into position. We place 2 from nums2 into index 2, and now p2 becomes -1. Because p2 is now negative, our while loop finishes. The remaining elements in nums1, which are 1 and 2, are already in their correct sorted positions. The merge is complete. Nums1 is now fully sorted without using any extra space. Now that we have walked through the logic visually, let us see how these pointers translate into our Python code. We define our function merge and initialize p1, p2, and p. The while loop runs as long as there are elements left in nums2. Inside, we compare values and move the pointers accordingly. It is a clean, one-pass solution that is both elegant and efficient. Looking at the complexity, the time complexity is O of m plus n because we perform a single linear pass through both arrays. The space complexity is O of 1, since we are modifying nums1 in place and not using any additional data structures. This is the optimal way to handle this problem in an interview setting. And that is the merge sorted array challenge mastered. Save this video for your next interview revision, and